Right. Hi there. Yeah, sorry for the delay. So I'm going to talk about CMake today. So just feel free if you have any questions, or if I say something you think that's wrong, or just say if you have any questions. Right. So let's go. So yeah, what does a build system do? So it orchestrates building a project. Good build system should try to be efficient and only rebuild what's actually required. So your sort of compile, link, run, debug cycle is short as possible, because you don't want to change like one line in a source file and then hit recompile and sit there for like half an hour waiting for it to recompile. You want it to be like as fast as possible. So build system should aim to do that. They can also try and detect properties of the machine. Well, by target system, I mean whatever machine you want your program to run on. So it can detect, does it have this header file, does it have this compiler, and you can build your program accordingly depending on what's detected. Build systems can also provide options, so say use this library or use that library. It can be a flag, and the user can decide when they're building a program, I want to use this or that. And it can also orchestrate testing if you feel like actually doing some testing. Okay, why should you care? Because you want your project to build as fast as possible, and you probably want to make your project portable. And also, writing your own build system is really boring and tedious. I don't know, has anyone ever tried writing your own hand makefile before, and then slowly see it spiral out of control? No, nobody. Yeah. So yeah, starting off with basic makefiles is fine, but as soon as your project starts growing and like, oh, I need this feature, I need that feature, it starts becoming a real nightmare to maintain it. So I'm going to try and persuade you to not do that and do something else.
Just have to call it fun and something.
Yeah. Cool. So I just thought I'd quickly overview some existing C and C++ build systems, just so you sort of know the lay of the land, so you can see what else is out there. So this is not exhaustive, but these are some of the famous ones. So as I mentioned, there's just handwritten make files. So you just have a file called a makefile, and developers specify targets and their rules. And this is fine for small projects, but it's really hard to maintain, and they're not really built for detecting things on your system, like for configuring, like detecting if you have this library, if you have that header file. It's not really built for that, but you can sort of hack it to do that. But it's not designed for that, and there's also no Windows support if you care about that sort of thing. So yeah, handwritten makefiles. Try to avoid it if possible. So one stage up from that is handwritten makefiles plus configure. So configure is just a shell script that basically tries and detects things in your system, like do you have a C++ compiler? Is it this version? Does it support this flag? And people used to sort of handwrite these shell scripts, and they were incredibly hard to maintain. So do not do this. Like if you do this, you are wasting your life, because this problem has been solved. So the solution that the GNU developers came up with was a bunch of tools that collectively together are called Autotools. And one component of that is AutoConf, which tries to generate configure scripts for you based on a file that you write that contains some N4 macros. And there's another thing called AutoMake that automatically tries to generate your makefiles for you, also using N4 macros. So it uses Bash shell, N4 macros, and Perl, and I think it's kind of disgusting, but it's what a lot of GNU projects use, and because they've been using it for a while, they're not going to change. But I wouldn't recommend you, if you're starting a new project, I wouldn't recommend Autotools unless you're a masochist.
Works well, actually.
Or no, works well on Unix. You try doing this on Windows. No, it's not going to happen. Because if you want Autotools to work on Windows, you basically need a full SIG-wind environment, which is basically virtualizing all the POSIX stuff. So you really don't. Yeah, if you don't care about Windows, then yeah, I guess Autotools is fine. But I tried using Autotools, and I really do not like it. Like the biggest pain point for me is the whole N4 macro thing, because you write them, but you might not be completely sure they're right, and so it generates a configure script. And then only then, when you run the configure script, do you know if you've done something wrong. And that's not the same with say CMake, which I'm demonstrating.
Yeah, I think also another issue is that for a long, up until recently, Automake was using recursive make. So if you have a large project with lots of nested directories, it's going to be extremely slow. I mean, there is now an option in newer Automakes to generate non-recursive ones, which improves things a little bit, but I think still Autotools are incredibly slow compared to some other tools.
Yeah, that's a good point. Just in case, just in case people aren't familiar, so with makefiles, there are two ways you can do it. You can have it non-recursive, where there is just one master makefile that specifies how to build everything in your project, and so there's just one. Or you can have a recursive makefile, where you have your project broken into folders, and each folder contains a makefile, and when you run make, it sort of recursively explores the directories looking for makefiles. The reason that is slow is because every time you go into a new directory, it starts a new make process. So basically, it's starting another copy of make and passing it, which is why recursive make is much slower than non-recursive make. So that's a bit of a divergence, but okay, never mind. So that's Autotools. Scones. I've used it, but I've never built a project from scratch using it, so I don't have that much experience using it. But so it's based on Python. The description of your project you write in Python, which is quite nice because Python is quite a powerful language, and because it's written in Python, you have native Windows support, which is also nice if you care about Windows. In my experience using it, it's a little bit slow, but that's just from one project, so take that with a pinch of salt. But if I don't really know a huge amount about scones, but if you want to find more, you can just go to the website and check it out. Then there's Ninja, which how many people have heard of Ninja? 2? Okay, so Ninja is basically, I would say it's make done correctly. So the ideas behind make are nice. It's just that the make developers added a whole bunch of stuff on top of it. So like having conditionals and having commands that expand to like executing shell commands and all sorts of other stuff on top of it, which make it more complicated. So Ninja basically gets rid of that, and in Ninja you only have targets and rules, and that's it. You don't have any of the other complicated stuff that makefiles can have. And it's also non-recursive, so it's fast. And I'll be demonstrating Ninja later on.
And it's also cross-platform. So
yeah, it's also cross-platform as well. I forgot to mention that. So it runs on Windows as well. Yay. So this is what CMake is. So CMake is actually a meta build system. So the diagram tries to explain it. So you describe your project in these text files, and then CMake reads that and then generates a build system of your choice. So you can say, oh, I want a makefile project, or I want an Eclipse project, or I want an XCode project, or a Ninja project, or a Visual Studio project, and I consider that quite useful. So you're abstracted away from choosing a particular build system. You just write this one file, and then someone on Windows can generate a Visual Studio project if they want. But say someone on Linux, they can take the same project and just generate a makefile, and it builds basically in the same way. So does that make sense to everyone? Any questions?
These are built into CMake. The logics of makefiles and Eclipse project.
Yeah, so all the logic for how to build the logic for building everything is in that CMake list.txt file. So everything about the project is in that file, and then CMake reads that and generates the equivalent in these different build systems. So if you want to modify your project in any once you've built the visual, once you've built the Ninja project, if you want to then modify it, you don't modify the Ninja file that was generated here. You just change this slightly and just tell it to regenerate. In fact, you don't even have to tell it to regenerate. It'll work out itself that this file has changed. I should regenerate the build system. Does that make sense?
Yeah, I was just wondering how you extend the output build system. That there's a set of build systems that are built into CMake, and he knows.
Oh, yeah. So CMake has this concept of generators. So you specify which. So that each of these So there's a generator for makefiles, there's a generator for Eclipse projects, there's a generator for Ninja projects. So CMake knows about these projects, and if you want to add an extra build system, you have to write the code for it. But yeah, but it's extensible, so you can add another build system if you want. So
It's just a different output format.
well, all these. Well, you can think of it. Yeah, you can think of it like that. Yeah. Cool. Any other questions? No. All right. Okay. Let's move on. So who uses CMake? So VTK and ITK, which is it's the visualization toolkit and the image segmentation toolkit. So they are actually the original users of CMake. So CMake is made by a company called Kitware, and Kitware also make these libraries. And basically, when they first started making these libraries, they wanted their library to work on Windows and on Linux, and they found they couldn't do it. So Autotools was no good for them. So they said, right, we'll make our own build system, and CMake is the result, basically. But that's good because lots of other projects can use it. So other notable projects that use CMake, LOVM and Clang, so the compiler framework. The KDE desktop, that's what I'm using right now. So KDE is built completely using CMake. MySQL and its very famous fork, MariaDB, so they both use CMake. OpenCV, the computer visualization library. Blender, which is a 3D animation tool, and there's a whole bunch. There's lots of projects use CMake. So there are free ways to invoke CMake, but a lot of people don't seem to be aware of this. So the first way is just as a command line tool, which is great for writing scripts, but it's not so nice for if you want to set options, which is what the other two ways are good for. So there's another tool called CCMake, which is sort of a terminal user interface. So it runs CMake, but it shows you this user interface where you can pick options like, oh, I want to switch this on, switch this off, or I want to change this file path and stuff, which is quite nice. And then another way is CMake GUI, which actually brings up a proper window, and you can click on things and open a file. If you want to change a path, it opens like a file browser and stuff. And you can, I'll show all three of these. Yeah, okay. There's one very quick digression, which is about building out of source. So, there are two ways to build a project. You can either build in source, which means all the binaries are in the same folder as yours. So the generated binaries are in a completely different folder from the source tree, and this is really good because it means you can keep your source folder tidy. It also means you can have multiple configurations built from the same source. So I could have a debug version of my program, a release version of my program, or a version with this library enabled, or a version with this library disabled. But you only need one copy of the source if you follow this model of I have one copy of the source code, and I build out of source, and my build directories are completely separate from the source. It also means you can actually delete your generated build files really easily. So if you build in source, that becomes really painful because you might accidentally delete your source code. If you're using something like Git, okay, it doesn't matter. But if you say if you download a tar or some source code off the internet and build it in source and decide, oh, actually I want to delete all the build files. If you use RM, it's a bit hit and miss. You might accidentally delete something. Yeah, there is make clean, but it depends how. If there's a bug in make clean, what do you do? Because sometimes there is. So CMake supports building out source out of the box. So I highly recommend you do this. There's very little reason to build in source. Right, tutorial. So I'm going to try and walk through actually just building a CMake project from scratch. Unfortunately, I didn't have enough time to put together everything that I was planning to. So unfortunately, I didn't get around to the unit testing, but I did manage a bunch of other things. So let's try. Already. I've already got it. Let's do it again. Okay, so yeah, that's the header file. Nothing particularly interesting. It's just one function, get a random number, and here's the implementation. Just returns 4.
Everything stays
Yeah. Don't know if, oh, that's not very readable. Let me do that on a different tab. And this is like the main function. So what main does, it just prints a bunch of stuff, and it loops a couple of times calling get random number. So not particularly interesting. So that's my source project, but there's no build system in this directory at the moment to build it. So I'm going to write one from scratch. So you write these CMake list.txt files, and they describe the project. And well, so you need to start with one like in the root of your source tree, and then you can add more as you go. So what's the project name? Yeah. So the first thing you need to say is what my project's called. What did I call this? I put my first lib, and you also need. I can't remember what that's called. I'll have to look that up. So, yeah, the man. Oh, that wasn't very big. The man pages are really useful. So you can do man, CMake commands, and all the commands are here. And there's like something. CMake minimum required. That's what it's called. And that's the basics. So now I'm just going to. Yeah. Sorry.
That's it.
No, there's more to it. I just want to show. So I've not specified like any programs. I just want to show that CMake will still pass this and not crash out. So I'm going to make my binary folder.
If that would be the minimal makefile, really impressed.
No, it's not quite that. So so I've made a new binary directory, and this is outside of my source tree. So there's the source folder there, and there's the binary. So now I can just say CMake and go into the source directory. So it did a function. So it looked at my C++ compiler, but that's it. It generated a few build files, but actually if I didn't make, nothing happens because I've not told it about what to build, which is not really very surprising. So let's go back and tell it to do some stuff. So I can never remember the name of that command either. So that's the one thing I don't like about CMake is its syntax is a bit funny, but it actually does quite a good job. What's it called? Program. Include directories, that's what it's called. So include directories. And so yeah. If you look, so there's a folder there called include, and that has the header that the project needs. So that's why I'm telling it to do this. And now directory. I think that's what I call them. So there are two directories here, lib and tool. So what this add subdirectory command is saying is go into that directory and then read another CMake list file in there, and that file will tell CMake what to do. So I'm going to just do that. I'm just going to make one. So touch CMake list txt. Cool, so now I need to tell it how to build the library, so I think the command is just add a library. And what's the name of the file it needs? Random superglue. So all what this command basically says is so make a new library, and everything after the name is a source file to use to build that library. So there's only one. And this
there's a typo.
Sorry?
My first library.
My fish.
Oh. Oh yeah. First library. Okay. First lib. Right. Okay. So the other bit to do is tool. Okay, so now the one I'm editing now is the CMake list in the tool directory, so which is where the tools thing can be built. So it adds executable. Yeah. So I don't call it my lib program, and that needs main.cpp, and then I will just say what's it called? I can't remember.
Search for space-based target.
Search for what, sorry?
Space-based target. So you only find the command.
Oh, yeah, that was a good idea.
Even more spaces.
Context. Sorry, I just have, there we go, target link library. Sorry, I'm not very good at remembering the name of these. So we have to say, that the executable is going to be called my lib program, and I want to link it against the my first lib target. So I think that is everything. So we've told it how to build the library, and then we've told it how to build the tool, the main program, and then how to link against our library. So now I should just be able to run. If I run make again, it should automatically trigger, because the CMake's list file has changed. It should automatically trigger a CMake to run again. So let's do So it did. So it's already done that, and now it's built it. So I can do tool and my program, and then it runs. Cool. Did that seem fairly straightforward? Other than me having to trying to remember what the commands were called.
Well, the question is how it maps to a bigger project. You don't want to enumerate every file manually.
Well, you don't want to.
You don't want to name each file manually.
I know in CMake you have to be explicit. You have to say this target is made of these CPP files. And some other systems, you don't have to do it. And there is a technical reason that CMake has to do that, but I can't remember exactly what that is.
But I think it's typically considered to be bad practice if you allow like star.cpp, because eventually it's going to bite you.
Really?
Well, because you just start adding new files and.
Yeah, but you want that. I mean.
I think there's been a lot of discussion on whether this is a good idea or not, and I think the general agreement now is that you should be explicit when it comes to these things.
I mean, I mean, if your project grows and you start with CMake, I really don't see it as a problem, because you'll be adding like a file at a time. You only have to do it once. It's not like you have to do it like every time. But once you've added that file to the list, it's there. That's fine.
That's something I have to remember. I would probably forget.
Well, if you forget, it won't build. If you forget, it won't build, and then you'll know exactly why. Yeah, don't worry.
So the project that you've shown,
Yep.
Does it mean that Autotools is the default build system for CMake?
No. Sorry, no. So the web thing, Make is the default build system here. So it's using when I generated this project. It used Make, but I can specify something else. In fact, I'll show doing other things now. So let me just complete. Where am I? I forgot the R. So okay, I'll just completely wipe the build directory. So the CMake GUI program I mentioned before. This lets you decide like which build system to use, like in a very easy way. So you can specify it on the command line, but you can also just run this. Oh, that's not very big, is it? I don't think I can make the text that much bigger, but the bit at the top here says, oh, where is the source code? The bottom here says, like, where do you want the binaries to go? You hit configure, and now it brings up a menu, and I can choose what I want. So I can say Unix makefiles, I can say Ninja, code blocks, that's an IDE. I can say Eclipse Ninja, Eclipse Unix makefiles, and apparently it has support for Sublime Text as well, which I don't think I'd ever use, but it's there. So let's do let's do Ninja because I've not shown that. So set finish. And also the nice thing about this GUI is it actually gives you any options for the project. They appear here. So if I want to say the build type here, I can say debug. Oops, not capital. Say debug, and I can also choose like here where I want it installed. So let's just configure again. Generate. Now if I exit this, the build files are here, but there's no make won't work now because there's no make file in here. But so I can use the Ninja program instead, which, as I said before, is like a super fast version of Make. So I hit Ninja. There we go. My project's built, and again, my program's here. And I might just show one more just for fun. So let's do the same again. But let's do Eclipse this time. Let's do Eclipse. Let's make files. And actually, you probably notice here as well. There's actually options for doing stuff, doing cross compiling here. It's not something I've ever had to do, but CMake does have support for doing stuff, doing cross compilation, which is also quite useful. So I've generated that. And now, so there's make files in here, so I can run make and it'll build it, but there's also an Eclipse project hidden in here somewhere. .c project, which is, I think that's the file that's probably used by the CDT plugin for Eclipse. But yeah, let's try that. Have I still got Eclipse open? No, I have not. Let's fire it up. And wait 5 minutes for it to start. Pardon? Oh, no, Eclipse is slow. Eclipse is so I can go to import. Sorry. No, it's quite nice for debugging, but for source code editing, I find it quite slow. But whatever works for you. So under general, you can go to existing project. So I'm importing an existing project into the workspace. Say next. I select the root directory. So that's. Tutorial, and so I point it towards the binary folder. That's where the .c project file was put by CMake. It's found it. Finish, and there we go. So now Eclipse is aware of this project, so it knows where the binaries are. Eclipse even tells me about the symbols. That's kind of cool. But yeah, so it knows also about the my first library, for example, and I can tell it to project. I can tell it to no, it's clean. They go on. Console, I can tell it to build again. Yeah, so it's built. So yeah, that's one of the nice things I really like about CMake is its ability to generate these different build systems, and you can use whichever one suits you. I mean, if you really like Eclipse, sure, you can generate an Eclipse project, but you don't have to do that. So as I mentioned, there's also Visual Studio support, but because I'm running Linux, it didn't show me that option, but if you're on Windows, it'll present like, well, would you like to build a Visual Studio 2010, 2012 project, for example. What did I get to? So there was one other thing I didn't. I said I'd show you all three tools, so I thought I'll just show you this one as well. So there is the CMake tool. So say if you're doing some remote development and you don't have a GUI, but you still want a nice way to pick the options, you can use this tool. So if I hit C, it's the same sort of interface, so I can change things here. So I want to debug, and you can change options here. Press C to configure again, and then press G to generate, and then hey, I've got my build system, and I can build. So does that sort of all make sense? Any questions about that? Tomac?
If you download a project that's already using CMake,
Yep.
and let's say they configure it in a way that generates Autotools, so make files.
It doesn't generate Autotools, it just generates a make file. But yeah.
That's good.
Yeah.
And if you want to change C flags or a compiler that's used, how do you do that in CMake?
In CMake, so either they will they'll either provide an option. So when I was in the this is actually a really nice thing as well. So you can actually go back and retroactively change your configurations. You can actually type make help, it actually shows you all the options, and you can do make edit cache. and it will bring you back here so you can change stuff. But often there will be something that they will provide you with a flag here, or I'm trying to remember what it is. I think there's an environmental variable you can specify, but without looking it up, I wouldn't be able to tell you exactly what it is. But my
Is it the CMake _ C compiler, something like this?
oh, if you want to specify the compiler, you can probably actually. I think I have Clang installed, so we can probably. Yeah, I've got Clang installed, so let's try that actually. So CMake. I'm pretty sure it just reads your the standard environmental variables. So we can probably say here, /bin/Clang. So that'll probably work. Yeah, so it's found. So it found Clang for bit 1. Now if I build in bit 1, if I do make verbose equal 1, you'll see that it. Oh, let me clean so you can actually see it run. Let's look up a bit. Is Clang there? Oh yeah, so just under the thing that says 50%, CDs into the right directory, and then it invokes Clang. So yeah, well that's how you pick the compiler anyway. And for the CSX flags, I don't remember off the top of my head, but there's definitely a way. There's definitely a way to do it. My guess, if I was guessing, I would say you can probably do this, and hopefully it will bail out. Oh. Yeah, so actually I can just say CSS flags equals this, and it'll bail out because of that flag I just specified, because it's not a real command line option. Well, does that make sense? Any other questions?
How about the different hardware platforms?
About different hardware platforms. There's, because I mostly build on the same. My target is usually the host, so I usually build on the same thing. I've never actually had to deal with this, but there is in CMake there's a way. I believe what you do is you basically write what's called a toolchain file that basically tells CMake how to use your cross compiler, and then you tell CMake about that, and then it will try and build as normal. That's my understanding of it, but I've never used it, so I don't know. But I know the features are there because on the wiki there's a whole bunch of stuff about how to work across compilers. So, is there anything else? Also, I mean I don't know how much more people want me to do. So I did actually. So I made a Git repository, and I did a lot more on this project than just this thing. So I did what I've just done here, but then I did a whole bunch of other stuff. But I don't know how interested people. Let me just. How interested are people in seeing more stuff? Because what I've shown you is really basic. You want to see more stuff? Okay. Right. What did I do next? So the next thing I did, I was like, I'd like to link with Boost. So let me just check that out. Am I not on? I'm not on I don't think I'm on a branch, am I? What? Okay, there we go. So, so actually, nothing is changed here. So I decided the next thing I would try and do is demonstrate using Boost. So what would people prefer me to show first? The code that was the C++ code that was added, or just the CMake stuff that was added? Okay, let me just open a new one. So what I had to do was add one line that said find package Boost. Required basically means if you don't find it, like abort. And I want this, but if I didn't want the Boost program options library. To understand actually how this works, something that's very useful to know is when you call find package, what CMake does is the first thing it tries is it looks in a special directory for files called findboost.cmake, and I'll show it to you. Actually, this is it actually. So let me just show you where. So on Linux, there's this folder which is in USR share CMake/modules. And actually, if I just do an ls in here, you'll see there's a whole bunch of stuff in here. So these are pre-written CMake scripts that people have made, but there's ones for like finding IDK, finding Java, finding Python, finding LaTeX, and all sorts of stuff. But if we just open this, so the comments here basically tell you how to use this particular find package. So basically, if it succeeds, what it will do, it will set a variable called, oh, I didn't mean doxygen, sorry, I want boost, didn't I? Sorry. Boost. So if it finds boost, it will set the boost found variable. It will set the boost include directories variable, which says what the include folder is for the header files, the boost library directory, and also the names of the boost libraries. Okay, right. So now we go back here. So I've used one of the variables here. So I need to add into this include directories command that it needs to search. Also in this variable. It needs to search in the directory containing the boost headers. And there's one other, oops, sorry, didn't want that. And, sorry, press the wrong key. And there's one other bit that has to be modified as well. Oops, not that one. That's the, no, I. Yes, except rule form. There. Okay, so this one at the bottom here. So this is the CMake's file in the tools directory, and basically all I've said now is, in addition to linking with my first lib, you need to link with whatever this variable expands to. And yeah, that's.
How would you specify to link it statically?
Statically, you actually it depends on the package. But for the boost one, where has it gone? For boost, there's an option. There's an option you can put in here, which is I think static, which means I want to use the static ones, and it's documented in here somewhere. There's something about using static. Yeah. So if you want to use the static versions, you can. But I think by default it'll do the dynamic. So a quick look at the C++ source code. So all I've done is rip some source code out of from this particular example here, just added it to the beginning. Basically, it just adds a command line parser, the boost one. So now that's all there, let's just rebuild. So it's built, so now if we take a look, we should see, I chose the wrong, let me just delete this and just do that again. So I used a different name when I was hacking this together quickly. Now I use a different name, which is probably confusing people. So I'll just build everything again. In fact, it also, if you look when that ran, it said it was looking for boost and it found boost 1.55. Right, so let's build. And so yeah, let's run our first tool. So it works as before, but now it has a command line parser. And if we look, we'll probably should find that was, yeah, so that was dynamically linked against boost program options. Does that make sense? Any questions about that? No? Right, okay, what was the next thing I wanted to do? What did I do next? Right, okay, so the next thing I did was I wanted to have a go at making the header files and the program we wrote and the library installable, and I'll show you what the code looks like for that. Let me just clear everything out. So targets. Did I close it in groups? So what did I change? Alright, so to install stuff, it's also pretty straightforward. So this is the CMake list file for the tool, and I've just added this, just like that. Just added this command here. So install. So you can list more than one target here. That's why it says targets, but I've only listed one target, which is our tool, which is called my first tool, and I've said the destination is CMake install prefix is a variable you set earlier on, and so it's going to go into the bin directory. And similarly for the library, I did something quite similar. So I said for my first lib install target destination is going to go here. And for the header files, I had to do that with something ever so slightly different. So before we weren't actually in the old version of the source, this had subdirectory included wasn't here, so I've had to add that. And now if I go in here, there's a CMake list file in here, and that says install the directory mylib, which is this one here. Install it here, and only copy files that match this pattern. So the reason I put this here is because when I did this the first time, I forgot the files matching pattern, and it accidentally accidentally installed my vim swap files, which you don't really want. So that's why there's a files matching pattern there. Right, so let's just, where am I? Let's just run make again, just so we can figures. Right, so I can type make install now, and it probably won't work because the installation location is probably set to USR local, so it should deny me. Yeah, so it tried to install it to USR local, and that didn't work. And the reason for that is if we go and make edit cache, we can see that this is that's what it's set to. But we can, I don't know, we can change it to something different. I can make a directory here, and let's do. Oh, that was unexpected. Don't do that, please, bash. So let's take that path and make it cache and pop this in here. And let's do make install now. And it worked. So yeah, so it's well, it's told you where it's copied stuff. And if we look install, yeah, it's all there. So bin, that's the program. Lib. Oh yeah, it's there, and include, we have lib. Cool, does that make sense? Cool, right, which stuff? Okay, so the last thing I worked on, which is a little bit more complicated, but I'll try and go over it, is adding doxygen support. So I don't know if people are familiar with doxygen, but doxygen is a tool for automatically generating documentation from your C or C++ code. So you annotate your program with special comments, and when doxygen passes that file, it interprets that as documentation, say, for this function or for this class. So it's quite nice. So I added support for running doxygen. Unfortunately, I didn't quite finish it. So the CMake bit works perfectly fine. It's the doxygen bit that doesn't work properly. So it's been a long time since I've set up doxygen from scratch, and when it generates the documentation, it generates it, but it doesn't document anything, and I haven't figured out quite why. But the CMake bit is fine. That's absolutely fine because I've done that a lot, and yeah, the CMake bit's fine. It's just I've obviously set a doxygen option wrong somewhere. So actually, but yeah, let's just demonstrate this. So let's just run make again. So would it be more helpful if I show you the code, CMake code I added first, or do you want me to just demonstrate that the doxygen generation works? Okay, CMake code. Right. So what code did I add? So I wanted to look into another subdirectory called doc, which I've added. And if we go into doc, this is the interesting stuff. So there's this command configure file here, and basically what that does is it reads in a file in the current directory, which is called, in this case, it's just called doxyfile.in, and it does variable replacement and then outputs that file into a file called doxyfile. And this only says only do at replacements, and I mean, I'll show you what that means, but basically when you have this configure file command, it will read any variables that are currently in scope, and it will try and substitute them into this file if it can. And I mean, I'll show you what the doxyfile.in looks like so that it makes more sense. Okay, so this is, I didn't write this myself, so there's a wizard that automatically generates this doxygen file, which is probably where I made my mistake. But see, for example, here's one. So for a project name, instead of putting the project name in, this is a CMake variable that will get expanded when it runs the configure command. And similarly, there's one, so the output directory, so where to put it. So I told it to do it in a CMake binary directory and put it in the doc folder. And there should be another one around somewhere. So the input as well. So this is the directory that doxygen is told to search. So I put that variable there. And oops, let's something like that. So oops. So that's what the configure command does. And and then there's a line find package, which basically tells CMake to find where doxygen lives. And then I have this command here, which is add custom target, which adds a target, and you can tell it to run whatever command you want. In my case, what I told it to do is, so doxygen executable is the doxygen program, and then the argument the doxygen takes is the path to the doxygen file, which is what we created here in the first line. But I mean, I'll run it now, so it will probably become more clear what's going on. So let me just run the make again to make sure it's generated. So now we're in the build directory. Now if we look, there's a doxy file here which was created by CMake, and if we take a look inside, it will have done the substitutions that we wanted. So earlier, where's project name? So yeah, project name in the doxy.in file there was an CMake project name or something like that. There was a variable substitution here. Now it's done the substitution here, and similarly for the output directory and for the other directory. If you remember before, I created my custom target is called doxygen. So now if I run make doxygen, it ran. But this is where it slightly falls over because I've misconfigured doxygen in some way, and so it doesn't generate the documentation in quite the right way. But I can still see it. So it's generated it, and it knows about these files. Oh, it worked. This wasn't working earlier. Brilliant. Oh, it's not quite working right. So yeah, I've documented this, but I've configured doxygen slightly incorrectly, and it's not worked. But the way you normally document things is you add stuff to the header file. So for random here, I've added this special doxygen style comment where you basically just put an exclamation mark after it, and then you write things like this: function blah returns blah. So it's a bit like Javadoc, if you've ever used that. But that's basically doxygen. Okay, there's one, I guess, I probably don't have time to set up a whole test suite. That would take a little bit too much time. But one thing I haven't shown you actually is configuring options, so maybe I should quickly show you how to do that. So I've added this ability of the build system to generate doxygen, but maybe a user might not want that. So I can add an option to CMake that lets the user switch this on and off. So I'll do this. So I'll go into the root CMake project and I'll add, I can add it anywhere, let's add it here. Option, what shall I call it? Let's call it enable docs. Sorry, I don't exactly remember the syntax for this. Help string initial value, okay. So you can put that all there. And I'll set this default value to on. And then I can put some sort of condition around this and say if enable docs. builds. Okay, so that's fine. And in fact, I can also stick a little message in there if I feel like it as well. So message. Because I set it the default to on, it will probably show. So yeah, you see the message there. Hey, you're building doxygen and stuff. So at the moment, doxygen target is still enabled, but now if I do make edit cache and so go in and change an option, I can go in here and I can disable enable docs, reconfigure, and then regenerate the build system. And now the make doxygen target doesn't exist anymore. That's pretty much it. And you can do much more advanced things with the options as well. It doesn't have to be Boolean options. You can have file paths and whatever you feel like. What time is it? Yeah, I guess that I should probably stop there. So there are many more advanced and cool things you can do with CMake. I've basically only scratched the surface of like what you can do. So I was deliberately trying to show you simple things to show you how easy it is actually to write your project using CMake. But yeah, there are if you take a look at the wiki, there's lots of cool things.
We'll just look at the LLVM CMake file.
Yeah. Oh, so that one's quite complicated, but let's have a look. So was there anything else? I think there were a few slides. Oh, yeah. So if you want to take a look at the source for what I've done here, so I've stuck it on GitHub already. So if you want to take a look and just play with it, it's there. And yeah, getting help. So these are incredibly useful. So there are built-in man pages. So there's man CMake commands, which documents all the CMake commands. There's CMake vars, which documents all the CMake variables. So something I didn't talk about at all was properties. So targets have properties. So a library and executables, they have properties, and you can get and set them. So one thing that's quite nice is for a library, you can set this public header file property, which basically associates whatever header files you want with that library. And what that means is when you install the library, it will you can set it to automatically install those associated header files as well. But there's a whole bunch of other properties you can change as well, but that's just like one of them. And CMake modules just documents some of those, some of the CMake modules like I was using earlier, like the find doxygen, find boost, and other things like that. And also the wiki's not bad. I wouldn't say it's perfect, but yeah, if you're stuck, you can take a look at the wiki, and if you're really stuck, you can try the mailing list as well. But yeah, I guess that's CMake.